Welcome to Insight Hub, the video series dedicated to the world of data and brought to you by Miracles Data Practice.
Hi, I'm Samanvita Burle, working as Research Associate in AI and ML in Miracle Software Systems. Today, we'll be discussing about exploring automated ML using Azure Machine Learning Service. So without any further delay, let's get started. This is our today's agenda. Initially, we'll be learning what is automated ML, followed by the architecture. Then we'll see different algorithms like classification, regression, and time series forecasting models, and then followed by ensemble models. We'll also see a live demo about forecasting electricity production using Azure Automated ML Service. Let's get started. So what is automated ML? AutoML is the process of automating the time-consuming iterative tasks of machine learning model development. It allows data scientists, analysts, and developers to build ML models with high scale efficiency and productivity, all while sustaining model quality. So, traditional machine learning model development is resource intensive, requiring significant domain knowledge and time to produce and compare dozens of models. So, there are many automated ML service providers like IBM, Azure, H2O, and Google. Data scientists can use automated ML to implement ML solutions without extensive programming language. They can save time and resources because it is easy to use, leveraging data science best practices, and also providing agile problem solving. It also gives us fast results. So in the PPT slide, you can see there is a pipeline. In the diagram, you can see that is the pipeline that is generally used for model development. Initially, there should be a raw data which should be collected according to the problem statement and according to the algorithm. Once the raw data is collected, the data should be prepared well using some transformation techniques. Once the data is prepared, it should be given for model training, and the trained model should be tested using test data set, and then it should be deployed. So this is the process that is followed by any machine learning model building. Let's see the architecture. So from the diagram, as you can see, the inputs that the user should give are the dataset, target metric, and constraints. After we load the dataset, we need to figure few settings depending on the dataset and algorithms we want to use to get started with the run. These settings generally change depending on the datasets, model types, and also they vary for classification, regression, and time series model. We shall also get to know more about them when we go ahead with the demo. So during training, Azure Machine Learning creates a number of pipelines in parallel that try different algorithms and parameters for you. Higher the score, better the model is considered to fit your data. So for automated model selection, we will have to choose the model type, like whether we want it to be classification, regression, or time series. Once we select that, all the algorithms for that particular model type will be used for generating the pipelines. Once these pipelines are created, they will be displayed on the leaderboard. On the leaderboard, the pipelines will be ranked based on the evaluation metric for the model type. The best model will be ranked 1 and can be used for deploying and creating an endpoint, which can be used for further testing process, and that can be used in other applications as well. So let's see what is classification and regression models. Classification, as we all know, is just a common machine learning task. Classification is supervised learning in which models learn using training data and apply these learnings to new data. Azure Machine Learning generally offers featureization specially for this task, such as deep neural network text featureizers for classification. The main goal of classification models is to predict which categories new data will fall into based on the learnings from its training data. Similar to classification, regression tasks are also a common supervised learning task. Different from classification, where predicted output values are categorical, regression models predict numerical output values based on independent predictors. So in regression, the major objective is to establish the relation between those independent predictor variables by estimating how one variable impacts the other. For example, automobile price based on features like gas mileage and safety rating and CPU performance prediction fall into regression models. And for common classification examples may include fraud detection, handwriting recognition, and object detection. So let's see what are time series forecasting models. So building forecasts are an integral part for any business, whether it's revenue, inventory sales, or customer demand. You can use automated ML to combine techniques and approaches and get a recommended high quality time series forecast. So, unlike classical time series methods, in automated ML, past time series values are pivoted to become additional dimensions for the regressor together with the other predictors. So, automated ML learns a single but often internally branched model for all the items in the dataset and prediction horizons. For example, when forecasting sales, interactions of historical trends, exchange rate, and price all jointly drive the outcomes of the sales. More data is thus available to estimate model parameters and generalization. Features extracted from the training data play a critical role. We can configure advanced forecasting, which includes deep learning as well. So advanced forecasting configuration includes time series and DNN learners. Many models support through grouping, rolling origin cross validation, configurable lags, rolling window aggregate features. When large datasets are given, deep learning models such as Microsoft Forecast TCN are used to improve the scores of the resulting model. Provides users with both native time series and deep learning models as part of the recommender system. So let's see another type called ensemble models. Automated ML supports ensemble models as well, which are enabled by default. Ensemble learning improves machine learning results and predictive performance by combining multiple models as opposed to using single models. The ensemble iterations appear as the final iterations of your run. They also will be included in the leaderboard. So these use both voting and stacking ensemble methods for combining the models. So voting models are something that predicts based on the weighted average of predicted class probabilities or predicted regression targets. Stacking combines heterogeneous models and trains a meta model based on the output of the individual models. The Corona ensemble selection algorithm with sorted ensemble initialization is used to decide which models to use within the ensemble. So if a new model improves the existing ensemble score, the ensemble is updated to include the new model. So let's get started with the live demo and see how the ML service works. So to get started with automated ML, we need to log on to Azure and launch the Microsoft Azure Machine Learning. We need to have a subscription and also a workspace ready to go start with the service. So this is the dataset that I will be using for the time series forecasting model, where we need to predict the electricity production for a particular date. So I'll also show you the automated ML. So this is how you can see the automated ML, and we have all the runs that we have created using the service. You just have to go to a particular service and view all the models that have been created. So there will be models that you can visualize, and also there will be outputs and logs. All the models that are created will be viewed on the leaderboard that we have already discussed, and for every model you can generate the explanation. So whichever model you would like, you can generate an explanation and you can view the explanation as well. So explanations will give you insights about the model, like how the model is being performed, and you will also get some information regarding the features that are important, summary of the model and everything. And in the metrics, you can just check the required metrics that you want to view, and you can view them either through chart or table. And once you're okay with that model, and you can go deploy it as an endpoint. Have deployed it as an endpoint, you will get a REST API that will be created, and the REST API can be used to check if the model is working properly or not, using Postman, or you can also go ahead and utilize in other web services as well. And you can also download the model, where you will get three files. One is model file, pickle file, and an API file. So this is how I have just copy pasted the endpoint, and we are giving it as a post API. And in the body, I have written the syntax like there's just this JSON input. And let's go forecast the electricity production. So before that, I want to show you the test data set. So this is the test data set that I'm using. I have only two features, as we have already seen, that is date and production. So for a given date, I need to forecast the electricity production. So I am giving the date 1/1/2017. So let's see if it can do it properly or not. So we have to send and see, I got it as 114 and we got it exactly the correct one. And now I will forecast to a future date, that is 1/1/2019 January 1st, and I am clicking send. Yes, it is almost exactly matching. And yeah, in this way you can utilize your ML models. You can create different types, different model types: classification, regression, and time series forecasting. You can either download the model or also utilize the endpoint in other applications as well. Thank you so much.
Thank you for watching a video on Insight Hub. The video series brought to you by Miracles Data Practice. For more videos, please visit miraclesoft.com/insighthub.